Hello everyone, my name is Putri Basenda Tarigan. I'm from Indonesia. I want to present about one topic in construction project, that is BIM. Building Information Modeling or BIM is becoming a comprehensive collaborative process in the construction industry. We all know that many projects nowadays, they are starting to adopt BIM. BIM can create a common language between all parties and system division in project and make them an integrated team. Yeah, so all people that involved in that project, they can access the project information through BIM. This table I got from a research paper. It's about BIM investment and return cost. When we want to use BIM, of course we need an investment at the initial time, like this, the red column, this one. But after that, we can also get a return by using BIM. So we get a return after our investment. So this is the return of using BIM. As we can see here, when the project use BIM, they invest 0.91% of the project budget. And after that, they can get a return about 8.18% of the project budget here. So what we can see from this table is that for all researchers, in all projects that they research, the percentage of the BIM return is higher than the percentage of the investment. For example, like this one, in here we can get 1% for the return, but for the investment it's only 0.00. Also for this one, we can get 14%, but the investment is only 0.04. So the return is still higher than the investment. So in this time, I would like to talk about the advantage of using BIM in our construction project. It's about the cost of using BIM and for not using BIM. So here I got a case study. This is also from a research paper. The project is Hyundai LCT The Sharp project. This project is located in South Korea, or more specifically it's in Busan. This project is a landmark and 2 residential towers. So it's like a high-rise building with the total height is around 411 meters. Before embarking on the project, the general contractor inspected the quality of the working drawings and judged it to be too low to direct use in the construction phase. So the general contractor checked the drawings and they think that the quality of the drawing is so low. So to solve this problem, the general contractor adopted BIM for diagnosing and managing potential risks likely to affect. Because when we execute the project that is wrong in the drawings, there will be likely a risk that will occur at the end of the time. So they established a BIM investment strategies by quantifying the various costs associated with design errors for errors prevention. They call this BIM assist design validation. So they built a model in BIM and they try to check based on the working drawings. And they also quantify the various costs that may result because of the error. So this will be easier because the design errors stemming from the design phase prior to the construction are comparatively easy to track by using BIM. Preliminary design error analysis during the initial on-site observation period. This is done by a panel of 7 experts in the field of structure, architecture, and also MEP. So they place around 3 experts for the architecture, 3 experts for the structure, and 1 expert for the MEP. So this expert will analyze the project based on the drawings, and their analysis revealed that most of the design error could have been easily addressed in the design phase. So after they collect the data, they collect the error and the mistakes that they found in the project. They classified into 3 errors based on the impact. So the first one is simple design errors. The simple design errors means that the errors that can be found easily and can be revised easily, like that. And then the second is rework design errors. Rework design errors means that when the errors occur, it will be likely to do rework or demolition after that. And then the third one is delay design errors. This is also one part of rework design errors, which will cause a schedule delay of the total duration of the project. So they found around 1056 cases for the simple design errors, 172 cases for the reworked errors, and also 32 cases for the delayed design errors. This is the example of the simple design errors. This one is discrepancies in the member size information. As we can see in here, the left one is the structural plan, and the right hand figures is a column core layout. We can see here in the left, the dimension of the C32 columns is 900 by 1.100. But in the right hand, we can see the C32 columns is 1000 by 1000. So the dimension is different, but the element is the same. The next is missing members. This is also included to the simple design errors. We can see here in the structural plan, there is a SRC3C column, this one. But in the column core layout, there is no SRC3C column. So this is also the simple design error. And the next, this is the example of the rework design error, the design error that will cause rework. We can see here in B1, B2, B4 floor plan, this beam is CB2 here. But in B3 floor plan, this beam is CB41. This is the beam model that they built. When we use CB41 in here, we can see here that it's not the same with the dimension of the opposite beam here. And this one is quantification basis of economic losses by design error. So the first table is simple design error. In here, they try to quantify the design error in cost. So they will calculate the cost of the error like that. So here, they assume that processing time, the revising time of the error for one case is 2 hours here. So for one day, which is 8 hours per day, the productivity will be 0.25, and the contract period will be 259 days. So in here, we will need 259 days to correct this problem. And then they will calculate the cost based on the labor cost per day, this one. So this is in Korean, about 264,000 won for one day for the labor cost. So they multiply by this, and this is the total cost of the simple design error like that. The next table is the design error that leads to rework. So they list all of the error that leads to rework, and they quantify the volume. And after that, they will calculate the cost based on the volume of the error. This is the unit cost that they have in Korea. And the next is the design error that leads to schedule delay. In here, they divide it into two types, which are beam impact not reflected and beam impact reflected. Beam impact not reflected means that we can find that error even not using beam. But in beam impact reflected, this is like the error can only be found if we use beam. So they calculate the quantity of the work. This is the quantity for the beam impact not reflected, and this is the quantity of the beam impact reflected. And then the productivity per day, they assume 48 cubic meter per day for the demolition and rework. And this is the schedule delays. We can see here that if we not use beam, the schedule delays will be 5 days. But if we use beam, the schedule delay can be minimized to 3 days. And here are all the errors that they find before starting the construction. They divide it into illogical design, discrepancies, and also missing items. Each of these errors can be found in architecture, structure, and also MEP. This is the total number of the errors that they find. This is around 1,000 errors. I think this is not a small number. This will affect to the total cost of the project at the end of the time. And this is the design errors of type 2, or the design errors that leads to the rework. We can see here that high impact, medium impact, and low impact, they just divided into 3 types. High impact means that the error can only be found with BIM, so this is undetected without BIM. So this will save 100% of the cost by using BIM. They find it in the tower, like this one. So this is the total number of the design error. And the next is the total economic loss. After quantifying the volume of the errors, they calculate the cost of the error. So this is the cost without using BIM, and this is the cost by using BIM. So for the type 1 error, the simple design error, the cost without using BIM and the cost by using BIM is the same. It's about 0.012% of the contract amount, which is 1.4 trillion won. But in the type 2, it's different. By using BIM, the cost is only 0.142%, but by not using BIM, it's around 0.224%. And then in the type 3, the delay design error, this describes a significant number, which is increased from 0.3 to 0.5. So for all, the total cost without using BIM is around 0.736%. But by using BIM, we can reduce it to 0.454%. So it saves around 0.282% cost of the contract amount. So this is the cost comparison. The type 1, this is still the same. For the type 2, we can save around 1.15 billion won. And in type 3, we can save around 2.8 billion won. So for the total, we can save around 3.95 billion won. Okay, so that's for this project. The next, we go to the benefit of BIM. Here I would like to talk about the benefit of using BIM. The first one is better collaboration and communication. By using BIM, all people in the project can communicate, can access the project by using Autodesk BIM 360, and they can actively collaborate to the project. And the next, model-based cost estimation. By using BIM, we can calculate directly the cost of the project. For example, by using Autodesk Revit, we can automatically calculate the cost of the project. And then the third is pre-construction project visualization. Yeah, by using BIM, we plan and visualize the entire project during pre-construction. We can visualize our project before starting to construct the project. So we can see our project even before it starts. And then we can reduce the cost also, like we already talked before, and we can improve the scheduling. BIM allows design and documentation to be done at the same time and can be easily changed to adapt the new information. When we want to change the model, it will change all information related to our change, like that. So it will be so helpful for saving time and also saving energy of revising the project. Here are some evidence that I got from research paper also. Most of the research paper, they talk about the benefit of BIM in the cost. They identify that most of the benefit of the BIM, they can save the cost, they can save also the schedule conflicts, like this. So that's all for my presentation. Thank you very much.